Hey guys, so in this video I'm going to be talking about equivalent fractions and also how to be able to take a fraction and reduce it into its simplest form or lowest terms. So that is a topic for this particular video. Okay, so equivalent fractions. Alright, so let's say I had this fraction right here. Okay, 1/2. It's a pretty simple fraction. Okay, so how can you get another fraction that is equivalent to this one? Alright, it's kind of like what we did when we were adding and subtracting fractions with different denominators, and then we changed those two fractions in such a way that they both suddenly had common denominators by finding the lowest common multiple between the two denominators of the two fractions, right? And you notice that I'd multiply, to find an equivalent fraction, I would multiply the numerator and the denominator by the same value. Okay, so this there we go. So let's say I multiplied 1/2. Let's say I multiplied the 1 by 2, and I'll multiply the 2 by 2. Okay, and we'll get an equivalent fraction of 1 times 2 is 2 over 4, right? So that is an equivalent fraction to 1/2. 2 over 4 is equivalent to 1/2. Now let's say I'd multiply 2 over 4. Let's say I want an equivalent fraction of 2 over 4. Well, then I could multiply, let's say, any number. So this time I'll pick 3 times 3 and times 3. Okay, so now I get what? I get 6 over 12. So all of these are equivalent to each other, right? So that's how you find equivalent fractions. You can also go the other way around as well. So, like I could have started with 2 over 4, right? And I can also derive an equivalent fraction from 2 over 4 by dividing both numbers by the same number. Obviously, you have to be able to divide evenly, right? So this will give me 1/2. Okay, so these are all basically equivalent fractions. So if I were to draw these in a diagram or in like a pizza form or a pie form, I'd get the same results. Okay, so this here represents 1/2 because 1/2 of the pie is shaded. Okay, now another circle with 4 pieces, and to represent 2 over 4, I'm going to shade in 2 slices. Again, the same amount is shaded in this circle as in that circle, right? And same if I had 6 over 12, so now I have 12 pieces. 4, that is, well, okay, this is 8 pieces actually. So this is also equivalent to 4 over 8. So I can show that here. Color in 4 slices out of 8. And then also if I had 12, these aren't the best circles. But I just want to try to at least get the message across. That's the important thing. So 6 on that side, and then I'll have 6 on that, so that's a total of 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I shade 6, 1, 2, 3, 4, 5, 6, out of the 12 pieces, again, I get the same for 4 eighths, 2 over 4, and 1/2. So they're all equivalent fractions. Alright, so now lowest terms. What does that mean? Lowest terms. Okay. Basically, what I mean by lowest terms is, so let's say we have this fraction here. 5 over 15. How can I reduce this into lowest terms? Well, I would need to divide the 5 and the 15 by the same number, and if I can do so, then I can reduce this fraction into its simplest form until I can no longer reduce it anymore. So until I can no longer divide the numerator and denominator by the same number. Once you can't divide the numerator and denominator by the same number anymore, you've reached the lowest possible form that the fraction can look like, right? So let's say I was doing an addition or subtraction question and I get a result of 5 over 15. Okay? Then, how can I reduce this or make sure that this is in lowest terms? Well, can we divide 5 and 15 by any number? Any one number, one specific number? Well, you can divide the 5 by 5, right? And you can divide the 15 by 5. So they both get divided by 5 evenly, so this is not lowest terms. Not lowest terms. Okay? So 5 divided by 5 is going to be 1. And 15 divided by 5 is going to be 3. Okay, so now, if I look at 1/3, can I reduce it anymore? I don't think so, because the most I can really do with this is divide them both by 1. I cannot divide them both by 2, because this will definitely won't give me a whole number, and this won't give me a whole number, right? And if I 3, 4, so on, right? So, and plus 1 over 2 is less than 1, so I can no longer get a whole number less than 1, obviously. So this is the lowest terms for this particular fraction. This fraction in lowest terms would look like this. Okay? So, this is in lowest terms. So both fractions are equivalent. They both represent the same thing. Yeah, right? So if you draw pi like this for both 5 over 15 and 1 over 3, you should get the same amount shaded in, 1/3 of the entire pi shaded in for both cases, right? And they're both equivalent fractions, but this is the lowest form it can take on. So if we look back to this over here, out of all these equivalent fractions, 1/2, 2 over 4, 4 over 8, and 6 over 12, which one would take on the lowest form, or be in lowest terms for all these equivalent fractions? It would obviously be the 1/2, because you can no longer divide 1 or 2 by the same number evenly to get evenly, right? Whereas here you can divide these both by 2, you'll reach 1/2. Here you can divide them both by 4, you'll eventually reach 1/2. If you divide these both by 6, you'll reach 1/2. So these 3 can be reduced into lowest form because you can divide both numerator and denominator evenly by a specific number. And eventually, you will reach this form, and then that would be the lowest form or lowest terms for this particular fraction. And you can no longer reduce this fraction any further than 1/2. Alright, so that's just a short lesson about equivalent fractions, what they mean, how you can represent two fractions as the same fraction, and also lowest terms, and talking about how you can reduce this particular fraction into its lowest, simplest form possible. So I hope you understood that, and if you have any further questions, just feel free to ask in the comments below, and have a good day.